Alrighty, we are continuing our study of optimization in our AP textbook. This is chapter 4.7. In our IB textbook, it's a combination of chapters 5.4 and a section in chapter 13. So we're going to take a look at a profit question today, profit, cost, revenue question. So if you're following along in your notes packet, this is on day 3, page 4. And the question says, when a manufacturer makes X items per day, the cost function is given as, there it is, in dollars, and the price function is given in dollars per item. Find the production level that will maximize your profits. Okay, so if we're trying to maximize profits, I want to make a function that represents profits. And I know that profits would come from whatever price I'm charging my customers. And it would be your price times the number of items, which I'll just call X. And that would give you your total revenue that you're taking in. But I need to deduct my cost in order to generate what my profit is. So in this problem, they gave us a price per item, which is why I multiplied it by X, but they actually gave me a total cost, not a cost per item. So we're going to make a little function here. So profits, I'm going to use capital P of X. They use little p of X for price, but capital P of X would be our price function, which is this 15 minus 0.002X times X items, which would give me my total revenue, minus my total cost, 720 plus 4X plus 0.02X squared. And we're just going to clean this up a little bit. So we have 15X minus 0.002X squared minus 720 minus 4X minus 0.02X squared. And if we're combining like terms here, I have negative 0.002X squared minus 0.02X squared, so that would be negative 0.022X squared. 15X minus 4X is 11X minus 720. So this is a function that represents our profit. And what we're really looking for is to maximize profits. And I know to find a maximum or a minimum, we find our first derivative, set that equal to 0, find our critical values plotted on a number line, and test out whether it is in fact a max or a min. So I'm going to find my derivative here. So 2 times negative 0.002, that would be negative 0.044X plus 11. I'm going to set this equal to 0. And we are going to solve. And by all means, use a calculator if you need to use a calculator. And we get a production level of 250. And so if we actually need to test to see if this is a maximum, in fact. So I'm going to come over here. I'm going to plot that critical value of 250 on a number line. And I know I'm not going to produce less than 0 items, so you can use 0 as a natural domain boundary. And I'm going to substitute numbers into my first derivative. So you can substitute 0 because it's technically not one of our critical values. So if I substitute 0 in, I get a positive answer. If I substitute something very large like a million in, negative 0.044 times a million is going to be much larger than 11, so I get a negative. So we do, in fact, have a maximum. So the production level that will maximize our profits is the production level of 250 items per day. Okay, so that was an example of profit and cost. Thank you so much for listening.